The first robot with self-consciousness, a new breakthrough in the creation of general artificial intelligence, evolving robots, a Japanese home for a space colony, and an unexpected turn in the fate of XPENG Robotics, and other high-tech news from the world of high technology in today's one episode. Let's roll! Scientists at Columbia University have created the first robot that's been able to recognize its body and learn to use it on its own, from scratch, just as babies do. The researchers placed the bot in a circle of 5 streaming video cameras so it could see its movements. Next, the robot used a neural network to create its own kinematic circuit, meaning it learned how parts of its body responded to turning on the motors in its joints. It then learned how to use it to plan its movements in order to reach its goal, avoiding obstacles in the process. It took the robot 3 hours to do everything. The robot became so aware of its body that it could determine whether it had injuries and where they are located. Thus, the researchers created the first prototype of a machine that can perform simple tasks on its own without prior training, as well as detecting its own wear and tear, and in the long run, repair itself. The first orbital flight of Starship prototype spacecraft could early as August, despite the explosion of Super Heavy launch vehicle. Remember that the pre-flight test of the first stage of the Musk Starship with 33 Raptor engines took place on July 11th, which ended in an epic explosion. Despite the clouds of fire and smoke that surrounded the rocket for several hours, it managed to hold on to the launch pad. The cause of the explosion, according to Musk, could have been from the fumes of cryogenic fuel, but the entrepreneur stressed that many sensors monitor it. After assessing the damage, Starship's anticipated launch date for unmanned flights has not significantly shifted. Researchers at DeepMind presented the PLATO algorithm, an artificial intelligence capable of building logic chains at the level of 3-month-old babies. Any high specialized AI easily outperforms humans in given domains, but algorithms are not strong at all in general thinking. Meanwhile, there's principles that we all understand from an early age, like permanence, where objects don't suddenly disappear, or solidity, solid objects can't pass through each other, and continuity, objects move consistently through space and time. Scientists have recently added immutability, where object properties such as their shape do not change, and directional inertia. Objects move according to the principles of inertia. All principles were demonstrated in a series of short-coded videos, on which the algorithm was trained. Next, PLATO tests showed that the AI learned the principles as well. It recognized their correct operation with any objects, not just the ones in the videos, and also showed surprise if it noticed a violation of the principles. This proves that the algorithm was able to understand basic physical laws and put its own knowledge into practice. Scientists from the University of Hamburg presented a new robot learning system and demonstrated it using a robotic arm as an example. The robot arm learned how to perform subtle and precise movements just by watching how a human hand performs them. The robot monitored the position of the fingers and joints of the human hand to understand how to best position its own grip and what force should be applied when performing the action. In other words, the robot learned by relying on visual data from a single camera. To estimate the necessary force, the system equipped with a set of pressure sensors analyzed the posture and character of human hand movements. This type of progress in the future will lead to quickly training humanoid robots in the necessary manipulation skills. It looks like we will live to see dexterous and intelligent humanoid robots after all. Engineers at the University of Glasgow have introduced electronic skin for robots to help them see. The flexible photodetectors created by 3D printing tiny gallium arsenide semiconductors can capture radiation from the ultraviolet to the infrared spectrum, and at the same time, the device operates at a low operating volt of 1. The authors of the technology say that the system's able to react very quickly to light, and the invention will give robots all sorts of new capabilities. For example, robotic arms working in light-sensitive environments will be able to detect changes in conditions that threaten their safety or effectiveness. Remember when we told you about XPENG Robotics' 4-legged robot? Admit it, did you laugh at the time? Well, since then, the company's made $100 million on it. That's how much it got for a project development as part of its Series A funding. The funds will be used for research and development in the field of robotics, hardware, and software. The company's first product will be the robot horse. The robot will not have to do industrial work like spot or animal. It will be solely a companion capable of caring for, entertaining, and transporting its owner. The bot will be equipped with a visual voice control, intelligent driving, target tracking, and will be able to work on different types of terrain. Japanese engineer from Kyoto University in Kajima and Kajima Construction are developing an artificial gravity architecture to make life in our outer space possible. Researchers believe that in order to explore the Moon and Mars, mankind will first need colonies in outer space, giant cylindrical spaceships with artificial gravity, including living areas, public transportation, green spaces, and water bodies. This is necessary because while adult health in low gravity can be maintained for some time, the birth and growth of healthy children under such conditions is impossible. Therefore, we need habitable objects that can generate gravity through centrifugal force as they rotate through space. The Japanese considered this prospect of migration to the Moon and Mars as real as early as the second half of the 21st century. Teams are also working on Hexatrack, an interplanetary transportation system for Earth, Moon, and Mars that maintains 1G speeds even during long-distance travel. And startup AI Space Factory presented Project LINA, a 3D printed lunar outpost developed in collaboration with NASA for the Artemis mission, whose astronauts will be based at the Moon's South Pole. LINA's ultra-thin shell will support 2.7-meter thick regolith walls, giving a lightweight, mass-optimized structure that will protect people from deadly cosmic radiation. LINA will be built by autonomous robots near Shackleton Crater, where near-continuous sunlight on the crater peaks and can provide solar power, while perpetual shade on the crater interior promises a good catch of water ice for the astronauts' needs. The modules will be built by a 3D printing system designed to operate in a vacuum at temperatures ranging from -170 to 70 degrees Celsius. LINA will be made from high-tech performance mixtures of natural lunar regolith and a polymeric binder of Earth origin. The prospect of a lunar base seems to be getting more and more real. Scientists at Virginia Tech have developed an electronic suction cup glove that mimics the unique muscular and nervous system of a sea creature. It senses objects underwater and sticks to them as well as a living prototype. The rubber suction cups covered with soft actuated membranes stick to flat and curved objects when lightly pressed. The suction cups are powered by a multitude of micro-LiDAR optical proximity sensors that detect nearby objects. A microcontroller connects the sensors to the synthetic suction cups to control their behavior, and at the same time, the sticking process can be customized by changing the sensor matrix depending on the task at hand. The invention can be useful for archaeologists and engineers servicing underwater objects as well as rescue divers. Space robot startup Get AI conducted a demonstration of its suspended system in a thermovacuum chamber. A two-armed autonomous robotic manipulator with a range of 1.5 meters performed maintenance, assembly, and manufacturing work. The system will be tested outside the ISS in 2023. During the technical demonstration, the robot will be installed outside the ISS Bishop ISS lander module, where it will perform a number of tasks in open space. Remember that Get AI is also developing a humanoid robot on a four-wheeled platform that can build structures and extract samples from the surface of Moon and the Mars. In Switzerland, the company Cargo South Terrain, which is going to build a network of underground tunnels for unmanned cargo delivery, will start a project this August. The concept was presented in 2016, but it wasn't until December of this year that the Swiss parliament passed the necessary legal framework. Cargo South Terrain works in the same principle as an automatic conveyor system. The drones pick up and move goods completely independently, moving through tunnels around the clock about 30 kilometers per hour. Goods are then transported on pallets or in modified containers. Thanks to refrigerated vehicles, it's also possible to transport fresh and refrigerated products. A high-speed suspension road for the small packages of goods is attached to the roof of the tunnel. The cost of the project is estimated at $30 to $35 billion for the entire 500-kilometer network, although about $3 billion should be enough for the first phase, namely the 70-kilometer stretch with 10 nodes that will connect Zurich to a logistics center in the west part of the country. Chinese media are reporting massive layoffs at Pudu Robotics. According to some reports, about 1,500 people lost their job. The company reported that this year is a forced measure in order to survive. The fact is, the robotics market in China has become hyper-saturated and competitive to the point that competition is out for the lowest price. And at the same time, the level of investment in robotics in the country has significantly dropped due to a downturn in the economy, which does not allow enough investment in the promotion of Pudu robots in the foreign markets where competition is not as high. Nevertheless, bankruptcy is out of the question, and the company promises to introduce a new product at the end of July. Computer vision researchers at Stanford University have created virtual organisms that evolve themselves and change their bodies for better adaptation. They unpredictably evolve their bodies and come up with their own method of movement. This combination of evolution and learning can help engineers create new kinds of robots. Scientists have found that although learning takes place in the brain, it's the body that influences exactly how this process takes place. Consequently, robots that develop their own bodies in simulation will be able to perform tasks better than those created by humans. We find the concept interesting. What about you? Let us know down below. Georgia Tech Robotic Musicianship Group and the Avshalom Polak Dance Theater unveiled the release of their collaboration. As a part of the project, engineers taught robotic arms to respond unpredictably to dancers, movements, and music. The goal was for both humans and robots to surprise and inspire each other. As the authors noted, if it's successful, both humans and robots will dance differently than before the meeting. Quokka Robotic Cafe unveiled a promo that makes it clear why production of the Pepper robot shut down. The humanoid robot, which is supposed to be the most dexterous and helpful in the cafe, in fact does nothing at all. It only attracts attention. And really, a huge rubber duck or flyer could do the same thing. Subscribe to the channel, like this video, and don't miss any new episodes from the world of robotics and high tech.